Welcome to another Tech Tip video, where today we have a little bit of fun in celebrating 75 years of Batman. We're going to look at an iconic piece of kit used by Batman, or in this case rather, CADman. CADman was highlighted at SolidWorks World 2014 when they sneak previewed the upcoming new features in the next release of SolidWorks. This piece of utility is used for launching a grapple up to a high-to-reach place and using some type of a microfiber line reels it in. This design can be considered quite complex in that reeling in all that wire requires a little bit of engineering. In this case, you can see that we're doing this with an electric motor driving a worm gear and a series of other gears to spool this up using a guide. We're going to show a few unique SolidWorks features that you can use to simulate this in your designs. To do this, we're going to go ahead and open the spool up in its own window, and again, I'll hide all the external components. When it comes time to reel the grapple in, the electric motor will spin this worm gear down here, and it'll reel in all the wire that's been sent out. You'll notice at the top of the design that we'll have a guide that'll make sure that the wire doesn't get tangled up on the spool directly below it. So how were we able to accomplish this inside of SolidWorks? Well, we did this with a series of unique types of mates that anybody can use in their designs called gear mates. Let's go ahead and start by looking at a simplified configuration where none of these mates have been added to the design yet. You'll notice when I switch configurations, I can now move all the components independent of each other. So we're going to reestablish or recreate these mates in this design. In this case, we're going to go ahead and initially line the gears up, though you could do this with a mate of its own to make sure that it's completely accurate. Likewise, in another video, I would like to show how to accurately create helical gears inside of SolidWorks. But for this exercise, we want to take a look at how to make this mechanism work using mates. To do this, we'll click the Mate button inside of SolidWorks. Within the Property Manager, you'll find all the common mates that most users are familiar and comfortable with, things such as coincident, concentric, parallel, etc. But further down the Property Manager are both advanced mates and mechanical mates. When you expand mechanical mates, you'll find a series of mates for solving mechanical designs. In this case, we're going to choose gear. Now when you use the gear mate, all you need to do is select two cylindrical or surfaces or axes on a part. In this case, I'll simply select this shaft and I'll go ahead and select this surface on the spool. You'll notice they don't actually have to be the surfaces that mesh with each other. You can pick anything you want. All that's required then is to specify the number of teeth on the gear. We'll do this in the heads-up display, and we'll specify that the top gear has 30 teeth and the larger gear below has 58. Then simply press OK, and now when you turn the gear, you'll notice that the other gear is driven properly off of the first. This is a great way to show this type of motion in your design and to make sure that your components are working properly. But it's not limited just to helical and spur gears. We can also use this in a worm gear configuration such as this down here, though the process is a little bit unique. Let's go ahead and simplify this by right-clicking on these two components and choosing Isolate so we can get a look at just how these two components interact. Like before, we're going to go ahead and choose the Mate tool, navigate down to Mechanical Mates, and choose Gear. Again, we simply need to select two cylindrical surfaces off of the two components. And again, you'll notice by default, it chooses the value using the diameter of the surfaces we've selected. This will be important in just a moment as we take a look at a more advanced way of mating with the gear tool. In this case, a worm gear is a little bit unique in that it's always a 1 to a specific ratio. In this case, it's going to be a 1 to 24 ratio. We'll go ahead and press OK, and you'll notice now that as I turn the worm gear, it's driving the gear, but it's doing it in the opposite direction. This is absolutely not what we wanted in this case. So again, we'll make sure that these are aligned. And how do we fix this? Going back over to the Feature Manager tree, I'll simply select one of these components. It'll be highlighted in the tree, and we can expand it and expand the mates that have been created on it. Here you'll see the gear mate that we've just created. We'll choose Edit Feature, and you'll notice that there is an option to reverse the direction of the mate. This actually means that you can use gears for things such as pulleys as well to accomplish the same results. though in this case we're doing it just to make sure we drive the worm gear in the correct direction. Let's go ahead and exit isolate and see what we've accomplished so far. Again, we have the worm gear at the bottom that is driving the lower gear, and we have this larger gear up here that's driving this alignment spool. So we need to finish by making sure that these two gears interact with each other. Again, I'm going to line these gears up just manually for right now. And I had mentioned previously that the SolidWorks Gear Mate tool will by default choose the value of the entity selected. I'm going to turn on several sketches that were used in the creation of these tooth profiles on these gears. When you generate a tooth profile in SolidWorks, there are three key values you're usually going to incorporate into your design: the outer diameter, the root diameter, and the all-important pitch diameter, which is used in any type of gear creation. The pitch diameter, if you were to look at it, is actually where two gears mesh with each other and interact. And you can see that my two pitch diameters here are actually tangent to one another. Well, when using the Mate tool and choosing gears, as I mentioned previously, when you select an entity, SolidWorks by default will select the diameter of that entity. In this case, the pitch diameter circle. This means that if you have these in your sketches, all you need to do is select them and press OK. Now, when it comes time to drive the gear, I didn't even have to enter the number of teeth in that design. It just automatically utilized that diameter value. So we can see that we've captured all the parts of our design and everything is working properly, except for this line guide right here, which needs to guide the wire as it wraps around this spool. This design was done with a unique type of mate. Let's go ahead and isolate a handful of components to get a closer look. When I turn on sketches again, you'll notice that this double helical path actually has a sketch that was used to create it. Likewise, when I look at this guide detent right here, within this sketch itself, I've created a few unique pieces of geometry. What we're going to do is we're going to use a path mate found in SolidWorks to make sure that this component is always aligned on that path. Now, I recommend getting these fairly close before you go ahead and start. From here, simply choose Mate, and again, we're going to go into Mechanical Mates, Advanced Mates, and choose Path Mate. When you choose a Path Mate, the first thing you need to do is select the vertex that will follow along the path. In this case, I'm going to use a sketch entity that was used in the creation of this detent part right here, which will actually ride in here. Actually, let's go ahead and change that to be the center of that detent, because as you can see, that path actually represents the center of that cut. Next, we simply need to choose the path itself. In this case, I'm going to select this sketch. You'll notice as soon as I did this that the original entity that I selected has locked itself onto that path. There are further options here you can select to control, but I've actually defined this with a series of other mates. Let's turn off these sketches now and see what happens when I rotate this gear. You can see that as this detent gets to the end of this sketch, it continues to follow along that spline. This is a great way to develop profiles such as cams or other things that follow unique paths along a design inside of SolidWorks. I'm going to go ahead and turn all these components on, and you can see how quickly it was for us to establish all these mates between these components and ensure that our design works properly in SolidWorks.